This is your spring review for your semester exam. Your exam will be 25 questions. They will be multiple choice. Starting with number 1 on our review, you've got the square root of negative 6x minus 2 is equal to 8. To solve this equation, you need to get rid of the radical. So you're going to square both sides. So then you get negative 6x minus 2 is equal to 64. Then I'm going to add 2. Get negative 6x is equal to 66. Divide by negative 6. X is negative 11. Number 2 is a cube root, so you're going to cube both sides. So that will give you 9x minus 10 is equal to 2 cubed, which is 8. Then you're going to add 10 to both sides. 9x is equal to 18. X is 2. Number 3, this is the 1/3. That's the same as the cube root. So you want to get this x to the 1/3 by itself. So you're going to subtract 1. You get negative 7 is equal, or sorry, negative 7x to the 1/3 is equal to 35. Divide by negative 7. X to the 1/3 is equal to negative 5. Now to get rid of a fractional exponent, you multiply by or you raise it to the reciprocal. So we're going to raise it to both sides to the third. So x is going to be negative 125. Negative 5 times negative 5 times negative 5 is negative 125. Evaluate the logarithm. So you can do this in your calculator, but you've got to go to math and choose the log base. So we're going to have log base of 1/5 of 125, and that is negative 3. Same thing with our next one. Log base 9 of 27 is 1.5. The fifth root. So you can get any root. I'm going to go ahead and put my 5 right there because I'm looking for the fifth root, and then I'm going to go to math, and I'm choosing number 5. That will put that 5 as telling it that's the fifth root of 8,018, and that is, and it told us to round to 2 decimal places, so 6.04. 78 to the negative 3 divided by 5 is 0.07. Find the product. So you can multiply across the top and across the bottom right here, and then cancel at the end. So 2 times 2 is 4, x to the 9th times x is x to the 10th, y to the 6th times y to the 4th is y to the 10th. I'm just adding those exponents. Divided by, that's going to give me 36, x to the 7th, y to the 4th. 4 goes into both 4 and 36, so that's going to become 9. So I'm going to have 9 on the bottom. And then I subtract my exponents. Anytime you're dividing, you can subtract those exponents. I'm going to have x cubed, y to the 4th divided by 9. Number 9, you're going to distribute, so you get 4x to the 6th minus 16x to the 5th plus 8x to the 4th. Number 10, you want to cancel on number 10 before you simplify. So I'm going to factor out in this, on the numerator on this first fraction, they're both divisible by 3x, so I'm going to have a 3x, and then I would have left x minus 3. On the bottom, the numbers that multiply to give me negative 15 and add to give me 2 are negative 3 and a positive 5. So I'm going to have x minus 3, x plus 5. Because I'm multiplying, I can just write these on the top two. Numbers that multiply to give me negative 35 and add to give me negative 2 are negative 7 and a positive 5. So I'm going to have x minus 7, x plus 5. And then right here I have 12x squared. So I have an x plus 5, top and bottom, an x minus 3, top and bottom. I have an x right here that will cancel out one of these x's, so I'll have just a single x instead of x squared. 3 and 12, that can reduce to be a 4 on the bottom. So what I've got left on the top is x minus 7 divided by 4x. Number 11, I'm going to work number 11 right here. 4m minus 4 times 4m plus 4. So 4m times 4m is 16m squared. 4m times 4 is 16m. Negative 4 times 4m is negative 16m. Negative 4 times 4 is a negative 16. These cancel, and I'm left with 16m squared minus 16. Write the expression in simplest form. Okay, you can, with roots, you can write this as the cubed root of 4 over the cubed root of 9. And you can't leave radicals in the denominator. So I've got the cubed root of 9. I know that 9 is 3 and 3, and I know with a cubed root I have to have 3 of the same factors in order to take that out. So I need another 3. So I'm going to multiply this by cubed root of 3 over the cubed root of 3. That gives me the cubed root of 12 on the top over the cubed root of 27. The cubed root of 27 is 3, so I have the cubed root of 12 over 3, and that is as much as you can simplify. Number 13, this one is already broken apart. I've got a 4 right here. I know that 4 is 2 and 2. This is a 4th root, so I need 2 more 2's. So I'm going to multiply both sides by both top and bottom by 4th root of 4. It gives me the 4th root of 28 over the 4th root of 16. I know the 4th root of 16 is 2. 4th root of 28 is my numerator. Number 14. I've got 4 terms, so I'm going to factor this by grouping. So I'm going to move my 32 to this other side. So that gives me w cubed minus 8w squared minus 4w plus 32 equals 0. When grouping, I'm going to look at the first 2 terms. Those are both divisible by w squared, so I'm going to take that out. And the next one, I've got a negative right there, so I'm going to take out, I can take out a negative 4 from both of those. That would give me w minus 8. These both have w minus 8. I'm left with w squared minus 4. That is a product of a sum and difference. The numbers that multiply to give me negative 4 and add to give me 0 are 2 and negative 2. So I have w minus 8, w minus 2, w plus 2 equals 0. So my answers right here are 8, positive 2, and negative 2. Number 15. This is a log equation. I'm adding the 2 separate logs so I can multiply their insides. So that would give me log base 6 of 4x times x plus 3 equals 3. Move my 6 over so I get 4x squared plus 4x times 3 is 12x. And I can change a log to an exponential by moving this base over 6 to become the base of my exponent. So 6 cubed, or you may prefer to write 216 right here. These are all divisible by 4. So that give me x squared plus 3x equals 54. I'm going to subtract 54. X squared plus 3x minus 54 equals 0. The numbers that multiply to give me negative 54 and add to give me 3 are a positive 9 and a negative 6. So those are my factors. X plus 9, x minus 6 equals 0. And my solutions are the opposites of those, negative 9 and positive 6. Because I'm plugging these into a log, I know I can't take the log of negative numbers. So negative 9 is going to be extraneous. My only solution right here is 6. Number 16, you're going to want to change this to a log. So the base of my exponent becomes the base of my log. So x is equal to log base 7 of 13. And we're going to go back to our calculator for that one. So we're going to go math, log base 7 of 13. And that is 1.318. Find the sum. So here we're just adding these, so that's going to give me a negative 13x squared, negative 4x and positive 10x is a positive 6x, negative 1 and negative 5 is a negative 6. Factor the polynomial completely. Okay, so I can take out an n squared, and then I'd be left with 3n squared plus 17n plus 24. 3 times 24 is 72. And the numbers that multiply to give me 72, and I got that by doing 3 times 24, and add to give me 17 are 8 and 9. I'm now going to divide those by this 3. reduce if possible, so that's going to be 3. So then I'm going to have n squared 3n plus 8 and n plus 3. That is completely factored. Find the difference. So I'm going to change all these signs and add them. All the signs on the second one. So negative 4 and a negative 6 is a negative 14x to the 4th. 9 plus 4 is 13x cubed. Negative 9, positive 10, that's a positive x squared. Negative 5, positive 10, that's a positive 5x. 3 and negative 8 is a negative 5. Find all real solutions. You can find this, because it's real solutions, you can find this in your calculator. Just go to y equals, type in x cubed plus 16x squared plus 83x plus 140. I'm going to go zoom 6. And I'm looking for where it crosses the x-axis. I can do that by going second calc, find the 0, where 0 is another word for x-intercepts. And I've got to go left bound, right bound, enter. That one is at negative 7. Left bound, right bound, enter. Oh, I chose the wrong one. That's negative 5. Left bound, right bound, and negative 4. Write a rule for g that represents the indicated transformation of the graph of the function. Reflection in the x-axis, that means it's flipped upside down, followed by translation 4 units up. So to make it a reflection, I'm going to put a negative out front. So I'm going to have negative 2 to the x, and then to move it up, I'm going to add 4. So plus 4. Write a cubic function whose graph passes through the given points. Okay, so because I have the x-intercepts, I can write this in factored form, which is y is equal to some value of a and then x minus these numbers. So this one would actually be x plus 4, x plus 2, and x minus 1. I can use this other point right here for my x and y values so that I can find out what this a is. So I'm going to have 4 equals a times 0 plus 4, 0 plus 2, 0 minus 1. So 4 is equal to, that's 4 times 2 is 8, times negative 1 is negative 8. Divide by negative 8. A is negative 1/2. Now all I do is I rewrite this a, negative 1/2, in where that a is. Copy the rest exactly as it already is. So negative 1/2, x plus 4, x plus 2, x minus 1. And I'm going to do that same process for number 23. So I've got y equals a, x plus 2, x minus 1, x minus 2. And negative 1, 6 are my xy, so I'm going to have 6 is equal to negative 1, a times negative 1 plus 2, negative 1 minus 1, and negative 1 minus 2. So 6 is equal to a times negative 1 plus 2 is 1. That's negative 2, and that's negative 3. So 6 is equal to 6a, so a is 1. So then I can just rewrite y is equal to, and I don't even have to write a 1 there. If it were any number other than 1, I'd need to write it, but with 1 it's just understood. Condense the logarithmic expression. Okay, so one thing to remember whenever condensing, if you are multiplying, you can, if you are adding, you can multiply the insides. If you are subtracting, you can divide. And numbers out front can become exponents. So this is going to be log base 7 of 2 times 8 squared divided by 4. 8 squared is 64. 64 times 2, or sorry, 64 divided by 4 is 16, times 2 is 32. You could put that in your calculator if you're not sure. That is your answer. Determine whether the inverse of f is a function and then find the inverse. You can determine if it's a function on whether or not it passes the horizontal line test, whether the inverse will be a function if it passes the horizontal line test. That means that no horizontal line can go through more than one spot, and that is true. So then to find the inverse, you switch x and y, so you're going to have x is equal to negative y cubed minus 2, and then solve for the new y. So I'm going to add 2, get x plus 2 is equal to negative y cubed, divide by negative 1, so that's going to be negative x minus 2 is equal to y cubed, and then I'm going to take the cube root of both sides. So my inverse is equal to the cube root of negative x minus 2. Use the property of rational exponents as fractions to simplify the expression. So 5 to this would be 5 to the first, or 5 to the any number over itself is 1. So I know my rule whenever I'm dividing is to subtract the exponent, so that's going to be 9 over 10. 5 to the 9 over 10. Find the inverse of this function. So again, switching x and y, so x is equal to e to the 3y. The inverse of e is your natural log, so you're going to have the natural log of x is equal to 3y. Divide by 3. Your inverse is the natural log of x divided by 3. Or 1/3 natural log of x. Determine whether the function is even, odd, or neither. So even is y-axis symmetry. Odd is origin symmetry. It looks the same upside down is another good way of remembering it. Or neither. So y equals, clear this out, 8x to the 5th minus 3x cubed minus 6. Trace. Alright, so it isn't even because it doesn't look the same on both sides. It's not odd because it looks different upside down, so then it is neither. Find the sum or difference. So here I'm just subtracting when I have the same denominator, so I'm just subtracting the two numbers on top, 7x minus 49. Those are both divisible by 7, so I'm going to factor out a 7. I have x minus 7 divided by x minus 7. My x minus 7's can cancel out. This is going to, so my answer is going to be 7 as long as this factor I canceled out isn't 0. So as long as x is not 7. Find all the zeros. So that's another, put it in your calculator and find your zeros. So x to the 4th minus 6x cubed plus 5x squared plus 24x minus 36. Alright, so this one right here looks like it's at negative 2. And yes, it's at negative 2. I just typed in negative 2 and hit enter. This one looks like it's about at 2. Yes. And then this one touches and then goes back up at 3. So we're going to list it twice. It's a double root because it touches and then goes back up. Graph g of x and then compare it with 1 over x. So comparing it just means to list what your transformations are. So I can see if I graph that, it's a negative, so it's going to be an x-axis reflection. And instead of this being a 1, it's 9 over 10, so it's going to be a vertical compression, because that number is less than 1, of 9 over 10. And if you're typing this in, you need to be careful that you, since you have more than one thing in the denominator, that you put in parentheses. And that's your graph. On your test, it will be multiple choice, so you'll be picking one. You don't have to graph anything on your test. Graph the polynomial function. So again, go back to y equals, clear this out, x to the fourth minus 2x cubed plus 4x and it looks something like this. And divide using synthetic division. Okay, this is multiple choice, so you can divide using synthetic or long division. With synthetic division, you use the opposite of this symbol, so you're going to have a -4, and then you use your coefficients. So it's going to be 1, 4, and -3. You drop your first number, then you multiply up and add down. Multiply up, add down. This first number is your remainder. This would be your constant. This is going to be x. If there's something else here, it'd be x squared, and then it just keeps going up. So I'm going to have x minus 3 over what I divided by x plus 4. If you wanted to use long division, you'd have x plus 4, x squared plus 4x minus 3. X times what gives you x squared? Well, that's an x. Multiply. Then you subtract. Those both cancel. Then I bring down -3. X can't go into -3, so that's my remainder.